Hello everyone, I'm going to record basically what I did in the workshops just for a different disease, as I know a few people were trying to record me in the workshops, but the room isn't really enabled for recording, so it's a little bit clunky to try and do it on your phones. So I've opened up the paper What is a Disease, and there's a link to it in the notes, so you should be able to click through and read the whole paper. And I've just focused in on a different one for this example instead of baldness, and I'm going to look at anorexia. So it's an interesting graph here where we've got kind of a heat map to show the opinion of whether or not people agree that anorexia is a disease, from dark green to being strongly agree all the way to strongly disagree. And we can see here that it looks like there's a difference of opinion between the lay people, doctors, nurses, and members of parliament. And so the question is, from a statistical point of view, would we see this kind of difference of opinion just through random sampling variation if the true underlying opinions of these populations were the same? Or is this an indication that there actually is a difference of opinion in these underlying populations? So let's open up the data and have a look at trying to replicate this graph here and then run the analysis to answer that question. Okay, so if we go to the variable view, we've got I have to remember to keep my cursor on the correct screen, otherwise you can't see it. So anorexia is down here, and remember that we've got the A and the B versions of the questions about whether or not it's a disease and whether or not the treatment should be publicly funded, and that might be interesting to look at both. Now all of these are listed as nominal, and technically they're probably ordinal, but it won't matter for our purposes here. So let's do a graph of anorexia, and the group of professional or person is this one here, group. So graphs, chart builder. And I'm going to do a stacked bar chart just to mimic what we have in the paper. You could do a clustered one. I feel that it would be easier to read as a stacked one, and looking at the thumbnail from last year's video, I think I did show some clustered ones, so you could go back and watch that if you're very keen. So we've got different ways that we could graph the data. I think it will be easiest to compare the results if we have a separate column for each group, and then we set this stack colour by their opinion. So let's have a look for the anorexia. Drag that in, and I'm just going to press OK. Now your colours, if you're in an earlier version of SPSS, could possibly be even worse than the colours that I have here. But before we go about changing colours, let's just have a look at what this is telling us. Now hopefully the first thing you notice when you do this graph is that we don't have equal sample sizes in the four groups. We've got about 1,500 lay people, I'm going to say about 750 doctors, nearly 1,000 nurses, and very few members of parliament. And this is down to not just the number of people that they asked to participate, but also the participation rates between the groups. And we can see that on the paper. They've done actually a really great flow chart of it. I should probably shrink that down a bit. And here we go, is a flow chart. So they started off by targeting or asking 3,000 lay people, 1,500 doctors, 1,500 nurses. So this started off the same, and 200 members of parliament, which makes sense because my guess is that's probably nearly all the members of parliament. They can't possibly have as many members of parliament as they have doctors and nurses. Then we look at the combination of who was eligible and the response rate, and we end up with 51% of the lay people participating, about 50% of the doctors participating, higher participation rate for the nurses, 65%, and lower for the members of parliament. So in the end, we've only ended up with 56 members of parliament. And we kind of need to keep this in mind just because once we start doing percentage charts, you lose track of the problem that we didn't have very many in that group. So you can clearly see on this graph that we don't have a lot of members of parliament, but the difficulty in looking at the graphs with the counts is that we can't compare the proportions across these different levels of agreement. It's very difficult to see proportionally, is this the same as this, and we can't tell. So we're going to redo this graph as a percentage graph. So I'm going to open up the chart builder again. On the side here, I'm going to change that to percentage. And you have to choose which way around you want to calculate the percentages. In most cases, it's probably going to be easiest to understand and to interpret if you do them out of each x-axis category. But there's nothing wrong with doing it out of each legend variable or out of the grand total, as long as you interpret it appropriately. So I'm going to do it out of each x-axis category, press continue. Now if you're in an older version of SPSS, you'll have an apply button down here, so make sure you click that. I'm so glad they've taken it away because I forget to click it all the time. But once it's clicked, you should see this change to percentage on the side. And again, we have complete nonsense in the middle, so just ignore that and press OK. So now we can compare across the different groups, and it should be much clearer from this graph that the proportion of doctors who strongly agree way higher than lay people and even higher than the nurses, and that wasn't really clear from this graph. Much more difficult to see. We still have the problem of the colours, so I would probably go through and change these. So just as an exercise in making graphs more readable, click onto this, and probably first I would actually shrink the graph down a bit. So what happens is people do this graph and then they cut and paste it into a report, and this font size is already very small. This is probably 6 or maybe 8. And then you put it into a report and shrink it down, and you just can't read it at all. So normally what I would do is probably shrink it down a little bit. Oh, that we're in inches. Let's say 4 inches. I can't think in inches. That'll do. And then I might also still change this font size. So I'll click on that to get the yellow outline. Now it says preferred size is 12. I don't think that's a 12. I'm going to make that 10. That's better. And I don't think we actually need this group here. We probably wouldn't even keep this title in because you'd put a figure legend in it for a report. You might have it in for a poster depending on how you're organising your poster. I'm going to delete that as well. Oh, I deleted the wrong thing. I don't know what I deleted before. And then maybe let's change the colours. So I'm going to repeat what they had in the paper and use the dark green for strongly agree, pale green for agree, yellow for neutral, bit of an ugly yellow, pale red and dark red. So that's looking better, and you could even transpose it. So transpose, I just did a right click then to get the transpose. So that's looking much closer to what they had in the paper. The other thing I could possibly do, turn that off, I could make it just a little bit wider. And then if I was doing a few of these together, I'd probably take this out as well, put that somewhere else at the bottom, and then put all of these together. But that's looking pretty good as it is. So the question that we started with is there genuinely a difference of opinion between, let's say, the doctors and the lay people, or even doctors and nurses, regarding anorexia as being a disease, or is this just due to random sampling variation? And I could probably get the percentages on there too, just as an afterthought. So elements, show data labels. Gosh, that's a bit ugly. Number format, no decimal places. That's better. I would actually probably take off that border. Yeah, I'm not sure I would keep those on there, to be honest, just because it looks so ugly, but I'll leave them on there for now. I guess I could take out the white background, that would help too. that'll do. So we're interested in testing the hypothesis that there is no difference in the opinion between nurses, doctors and lay people and members of parliament, but we know there weren't very many of them, in the population of Finland as regards anorexia being a disease. What evidence do we have from this sample that that hypothesis is wrong? And we always structure the null hypothesis as being something which is very precise so that we can calculate a probability on it. And it's always a falsifiable hypothesis or a nullifiable hypothesis, so it's a null hypothesis. And commonly it's that there's no difference between the groups. It doesn't have to be that there's no difference. We could actually test the hypothesis that doctors are exactly twice as likely to strongly agree that anorexia is a disease or something. We could calculate the probability another way, but it's usually easiest just to test that there is no difference. So let's go about getting this information as a two-way table. And we can do that under descriptives, crosstabs. Now mathematically when you're doing this, it makes absolutely no difference what's in the rows or the columns. If we want it to match up this graph, I would put the group in the rows and the disease in the columns. And this is what we get. And again, this is the count, so that's a little bit difficult to compare. But the counts are useful because it can help us illustrate where some of the numbers come from when doing the chi-squared test. And if you're okay with all the numbers, I encourage you to look up how to do the test by hand because it's actually not that hard. It's just a little bit time consuming when you've got this many categories. So the way the test works is we have this observed data and this is what we saw in the sample. What we can also do is calculate how many would we expect to find in each of these categories if in fact they all shared the same opinion. So the way that works is you kind of total up the total number of people or proportion of people who strongly agree and then redistribute it to work out, okay, if it was all the same, what would that average out to be? And then we look at how different it is from the observed, from what we would expect if the null hypothesis was true. So we can get SPSS to do that for us. So back to crosstabs and in cells, we can see the expected values. So this is what we would expect to see if there was no difference in opinion in the underlying populations. Continue, okay. So it says we would have expected if there was no difference in the underlying populations that 60 lay people would strongly disagree, but actually we got 112, and we would have expected about 29 doctors to strongly disagree, but actually we only got 7. So it looks like we've got a very big difference here between what we observed and what we would have expected if there was no difference. And the difference between what we observed and what we expected is called the residual. So we can also get that in the table as well. So if you were doing this by hand, you would go through and you would do each of these things on the calculator by hand. So the residual, I'm going to pick the unstandardized one just so you can see where the numbers come from. So the difference between what we observed as being 112, what we expected, and 60 is a difference of 52. And here we had a difference of minus 22 and we had a difference of minus 29. So these are pretty big differences. But remember that it's difficult to compare these raw numbers across the different categories because we had a different sample size. So something that we would do is, rather than look at these raw residuals, even though you need these when you're calculating the test statistic, in terms of evaluating what's going on, we would actually look at the standardized residual. And you can look up the standardized residual on the standard normal distribution, and typically anything getting close to minus 3 or 3 is large, and over 3 either direction is very large, and it's having a strong influence on the results. So I'm going to tick that off as well. Crosstabs, standardized residuals. Now the problem with looking at all of this is it's now getting very are difficult to look through. So what I might do is actually turn off all the other numbers and just look at the standardised residuals to see where the biggest difference is coming from. Obviously, if I was doing this analysis myself, I wouldn't go through all these steps. I would just go straight to it. So I'm going to untick all of those. Now we've just got the standardised residuals here. So this is a measure of how different the actual observed data was from what we would expect if there was no difference between the groups. And we can see that the proportion of people who agree is actually not that different between what we would expect. But the proportion of people who strongly disagree or strongly agree is very different. So this is giving us very strong evidence that there is actually a difference of opinion in the underlying population. But we can go through and actually run the test. So that's one more box to tick. Crosstabs, stats, chi-square. So we're looking at the first line here for the Pearson chi-square test. The value is 378, which is enormous. So if you've ever done this test by hand and you were looking up the p-value on a graph of the chi-square distribution, you'll know that'll be right out on the tail. And the p-value is very, very small. And I think you can actually see what it is exactly if you click into it. Do you have to hover over it? It's tiny, absolutely tiny. I'll click out of that. So we've got very strong evidence that the null hypothesis is not true, and therefore we would conclude that there is a difference of opinion in the underlying populations. So we could quickly have a look at if there's a difference in whether or not the treatment should be funded, just out of interest. So we had a look at anorexia A. I'll just have a look at anorexia B. Oh, there's a strong difference there too. So that actually mimics what we had with anorexia A. And if I go through and do I'll take that one out. And again, that's highly significant. So you could go through and have a look at a few of those. There are some cases where people don't actually think it's a disease, but they do agree that it should be publicly funded. So the two answers are not necessarily the same, even though in this case they were. Okay, well that's pretty much what I did in the workshops. It just took twice as long, of course. And if you've got any questions, please put it on the forum.